We want to welcome you all to our session today about building agents with knowledge, agentic RAG, and Azure AI Search. My name is Matt. I'm a program manager on Azure Search.
I'm Pamela, and I am a Python cloud advocate. Does it say to clap right now?
All right, let's talk about our agenda for today. First, we're going to cover the basics of RAG, retrieval augmented generation. Then, we're going to do a deep dive on knowledge bases inside Azure AI Search. We're also going to cover how Foundry and knowledge bases are connected through Foundry IQ, and we're going to have time to take some questions. Let's dive right in.
All right, so I'm going to talk a bit about RAG. So how many of you are using RAG today? All right, that's a very good number. Awesome. Now, just to get us all on the same page here, right? We're all building these applications. We're starting to build agentic applications and agents, and we're seeing agents in many different parts of our workflows, right? And these agents can be conversational. That's what a lot of us originally started building. And now we have more task-oriented agents that are actually taking actions and doing stuff on our behalf. Now, the majority of these agents need domain-specific context to ground themselves in your organization's data, right? In the information that matters for you, for your task. And that is where we need to have very good retrieval and very good RAG. So RAG is the name for the technique that LLMs use in order to use your information. RAG stands for Retrieval Augmented Generation. The basic idea is that you get in a question, you use that question to search a search index, you get back those results, and then you send them to an LLM and say, hey, LLM, here's the results, here's the original question or intent. Now please answer based off the results and provide citations, right? I actually have a demo that I can show of a very basic, the most basic RAG application, right? Of course, we're asking about 𝗲𝗲. What is the best 𝗲𝗲 paint for bathroom walls? It says it's the interior semi-gloss paint. Very important for washing when your children decide to draw all over your bathroom, as happens to me a lot. And if we look at the process here, what we do in this very basic RAG is we take that question, we send it to our AI search index, we get back results. These are chunks of documents that we've indexed, and they have file pages and scores. And then we send those results to an LLM and say, hey, your job, LLM, is to answer the question based off these sources. And so then we get back that answer with citations. That's the basic RAG, and that is what we have, many people started with in this space of RAG.
So let's talk a little bit more about Azure AI Search is actually going to help you run advanced RAG for better generative AI applications. Azure AI Search provides customers with a feature-rich vector database built on an enterprise-ready foundation, so you can focus on growth and scale. Its integrations offer an end-to-end data management pipeline for all types of data, a full-stack RAG solution available where and how you want to build. Your retrieval strategy matters. Our comprehensive search technology allows you to go beyond vector search. We ensure that you have the capabilities you need to retrieve accurate information for every question, regardless of your use case or data.
So how many of you are using AI search already? Let's see some hands again. Make sure everyone's listening to the right headphones. Awesome. Look at that, all your customers. Very good. All right, so the thing that's fantastic about Azure AI Search is that it has this state-of-the-art retrieval strategy. It uses a full hybrid search. So it's not just using vector search or just using keyword search. It is combining vector and keyword search together, merging those results using reciprocal rank fusion, and then re-ranking those results to get the very best results. So we're going to start off with talking through this search step so you all understand hybrid search, and then we're going to go on to all the new agentic search strategies that you can layer on top of hybrid search to get even more powerful results. So there's just so much stuff that AI search has to offer. But let's start with the basics, right? So keyword search is the traditional search that we've been using for decades now, right? And the idea of keyword search is that we store an inverted document index, which says, hey, you know, for this particular term, this is how often we saw in the documents and the general frequency relative to the length of the document. So if I'm searching for hose, and there's a document that says hose, 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 hose all over the place, that's probably a very good document for my, you know, for my search for hose, right? Now, Azure AI Search uses BM25, which is basically the best-in-class full-text algorithm, and does a very good job at handling keyword search. Let's see, I've got a little example over here with keyword search. So what I've got is I'm using Python, because it is the best language, and I'm setting up the Azure AI Search client, connecting to my search service, and then doing a search here for 25-foot hose, okay? And this is searching this, you know, fake 𝗦𝗲𝗀𝗶ecie product catalog that's got names, description, categories, price, etc. And what you can see is the very top result is, in fact, a 25-foot hose. So you can see here that keyword search did a good job. It actually found exactly what we needed, right? And it did a good job here because 25 matched, foot matched, hose matched, like, you know, like, it's kind of like an easy one for it, right? Now, the issue with keyword search is that it does much worse with other kinds of queries, right? So if I'm searching to figure out how do I water my plants efficiently without waste, now when I do keyword search, I can see the first result is water-based polyurethane. The second result is water-based wood stain. You should not water your plants with either of those. I tried, it just didn't work. So this is an example where keyword search just utterly fails, right? Because we asked this query that was much more broad, ambiguous. It didn't have, you know, exact keywords in it, and you know, and that's what keyword search does well at, right? So this is why people get so excited about vector search, right? This has really become big in the last 3 years or so when we came up with these new vector embedding models like the ones from OpenAI, text embedding, text 8 embedding, all of those great models. And the idea with vector search is that we take our information, we turn it into a vector, and that vector represents the information in this multi-dimensional space. And then when we get in a new query, we convert that into a vector using that same embedding model. And then we check and see, like, hey, for this vector, which vectors are the closest? And we go and we see, oh, okay, like for dog, cat is closest and puppy is closest, right? And we find which ones are closest. And the idea of that multi-dimensional space is to represent similarity. And it's, you know, it's been trained off the internet and seen generally what terms, you know, show up together in the internet corpus, right? So that's the idea of vector search. And with Azure AI Search, it has very good support for vector search. One of the first search engines that added it. And you know, you can use it on your documents, and you can also use it if you have massive vector databases. So it can actually scale to handle searching across billions of vectors, because it can use this approximation algorithm called HNSW, which can scale to huge amounts of vectors. So vector search is very powerful. So let's see a little demo of that. So we set up our search service again. And so now when we perform the vector search, we have our query. We're going to turn that into a vector, and we're turning it in the vector using Azure OpenAI, one of the text embedding models. And then when we search, we're going to only pass in that vector here. So I'm actually not passing in the text at all. I'm only passing in the vector so I can see what can I get with just that vector, right? What is the most semantically similar to that vector? So here I'm trying that, you know, the query that keyword search struggled with, water plants efficiently without waste. And this time the results are much better, right? So the very first result is a self-watering planter. Then we get our 25-foot hose. We get some tomato plant food. You know, and that's not quite as good. And then some planters. So maybe the ones it found that were really good are at the very top there. So there, you know, you're looking at that going like, wow, vector search was way better for that query. Can we just use vector search for everything, right? And you'll hear many people say like, oh yeah, just set up a vector search, just set up a vector database, that's all you need. That is not all you need. Because vector search can fail in so many ways. So we look for this example, a 100-foot hose that won't break. This is something I've been searching for my entire life. If anyone can find it, please tell me, because 𝗬𝗲 doesn't exist. So I really, really need this. So What we can see with vector search is very interesting. The top result is actually 50-foot hose, and the second result is 75 hose. The 100-foot hose is result number 3. And why does that happen? Well, in the vector embedding space, it doesn't really care about numbers. To like a vector embedding model, 50, 75, 100, they're all kind of the same thing. They're just like a number you put in there. Like, it doesn't really think that they're semantically that different. So we don't end up getting 100-foot as being the top result here, right? So this is where you can see where vector search, like it still did a decent job because it did find hoses, and we do see a 100-foot hose somewhere in there. But as a user, I might be thinking, wait, if you have a 100-foot hose, why isn't that just number 1, right? So what we're going to do is use the best of both worlds. So the first thing we need to do is we're going to take that search query, we're going to take that search vector, and we're going to use it to search with both keyword search and vector search. So we'll get back the results for each of those, and we'll have relative ranks in each results. Then we're going to merge them together using this algorithm called reciprocal rank fusion. And it sounds super fancy because computer scientists like to write papers with fancy names. But what it really is just looking at the relative rank and being like, oh, if this was like number 3 over there and number 5 over there, we're just going to kind of, like average those together and see what the rank ends up being, right? So it's a good way of like just representing the relative ranks across both of them. So we can go and check it out in our example. So here, in order to do reciprocal rank fusion, I'm going to take that search query, I'm going to take that search vectors, I'm going to pass both of those in. So here's the search query, here's the vector query, and then I'm going to look at the results. So this time, we still have a 50-foot hose as number 1, but that 100-foot hose did move to the number 2 spot. And that's just because of where it was in the keyword results and the vector results. That got it high enough to get to number 2. So here you can see that we are getting better by using the RRF. But we can get even better than that. So the next step is to bring in the re-ranking model. This is a particular kind of model. It is not a large language model. It is something called a cross-encoder model that has been specifically trained to look at a user query, look at search results, and then assign scores. And so this was actually trained with humans, where humans would look at search queries, look at results, and say, hey, I'll give that like a 4. That was really good. I'll give that a 1. That was really bad, right? I'll give it a 2. It was kind of meh, right? So you can actually look at it and be like, oh, I got a 4. That's a really good result. Oh, I got a 1. That's a bad result. We're just going to throw that out, right? So it's an incredibly useful ranking model to use. Let's see what happens when we use it for this example here. Now, in order to use it with AI search, we're going to pass in our query, we're going to pass in our vector, and we're going to specify that we want it to use the semantic ranker. So it's just a couple extra parameters that we throw in. And so then when we look at the results, we can see that the hose got up to the number 1 spot, right? Because the re-ranker model is actually looking at that original query and going, hey, they're looking for a 100-foot hose. This 100-foot hose seems like the best result for it. Now, it did some of the other ones, I'm kind of a little dubious about, but maybe it just didn't find better results there. And they're all kind of related to hoses that won't break, so I certainly wouldn't be against buying a lot of those things. But that's the point of the re-ranking model. It was able to hoist the most important result to the top that really matched that query. So if you are, using this hybrid search, you really want to have that re-rank model. The other thing that's super powerful about it is that we get the re-ranking score. It's hard to see it in this model here, but you can see it's like 1 and 2s. And so actually, if something's like, oftentimes we use a threshold of 1.9, and if it's less than 1.9, we just throw it out. We just say, hey, that's just not good enough. We want to have really, really high quality results. So that's the other nice thing about that re-ranking model is that it's absolute scores, where you can actually just say, after a certain threshold, we just think it's not good enough quality. All right. So this is the complete hybrid search flow that we showed earlier, right? We're going to do both those kinds of searches. We're going to merge them together, and then we're going to do that re-ranking step. If you are searching and you want really good search quality, you need to be using this stack. Azure AI Search is a great option for it. It is also possible to implement on top of a few other stacks as well if you need to do it. But AI Search has it built in, and it's just super easy to do with it. Now, the AI search team has actually done research in order to verify why it's so important to have this stack. And this is an example here where they looked at lots of different kinds of queries, right? We look at keyword queries, we look at short queries, long queries, concepts. There's so many different kinds of queries that are going to be thrown at your applications, right? If they're user-facing, like users write the darndest things, right? If you give a user a text field, like, oh my God, the stuff they'll put in there, right? So you have to be prepared for all these kinds of queries. And so they did all this research to show, like, listen, if you want the best results across all of those, you really need that entire search stack. So hopefully I've sold you on hybrid search. Now the thing about hybrid search is that AI search has supported this for what, maybe 2 years now?
It's been a couple more than that.
Yeah, okay. So that's all, it's almost old news, but I feel the need to talk about it because I don't think everybody realizes like how incredible it is. So you should definitely be using hybrid search whenever possible. However, today we're actually here to talk about when hybrid search isn't enough, when we need to build additional strategies on top of hybrid search, right? So here I have some examples of hard queries that we need to address with more agentic techniques, right? So the first example here is having multiple questions in one query, right? So this one is like, oh, what type of paint is most suitable for the bathroom? What's the price range of all these different options? Like they're asking a lot of things in one query, and it's not the kind of thing we can answer with a single search call, right? We actually have to decompose that question into multiple questions. A related kind of question is what I call a chained query. This one is like, explain how to paint my house most efficiently, then give me a list of the products that would help me, right? So in order to answer the second part of the question, we first need to get the search results for the first part of the question, right? And so that implies we have to do some sort of sequence of search calls. So that's quite interesting. And then the third kind is queries requiring external knowledge, right? So a lot of people expect your applications to both be able to search your data, but also just generally know things about the world, right? So they need to be able to search the web in order to answer those questions. So those are the kind of interesting queries that you're going to see in many of your applications that the AI search team has been figuring out a way to approach. So let's have Matt talk about that.
Thank you so much, Pamela, for that great introduction to RAG. But we're here today to also talk about knowledge bases inside Azure AI Search, because this feature is what's going to improve on top of those hybrid search strategies using agentic retrieval. So when we talk about agentic retrieval, here's specifically what we mean. Every knowledge base inside Azure Search has an agentic retrieval engine, which essentially the whole purpose is to find better context whenever you're trying to use RAG for agents and any kind of agentic application. The three core components of this engine are query planning, knowledge sources, and merged outputs. The first part of agentic retrieval is using an LLM to break down a complex conversation into individual queries representing the basic information need from that conversation. Now, part of this query planning process, it goes beyond just generating the queries. We're also selecting the knowledge sources which are necessary to answer these queries. These knowledge sources represent all the data that your agent would need to answer questions or perform any relevant tasks that it needs to do. The queries that are generated are sent to every selected knowledge source to gather the relevant documents. Finally, the results of these queries are merged together and are used to produce a single synthesized answer with citations. Now, if the agentic retrieval engine determines that the results found are not sufficient to answer the queries, it's actually going to take a second pass. It's going to repeat that query planning phase, taking into account the results it's already seen. So this is a very powerful feature that lets you get the best out of hybrid search and get the best context for your agents. So when we talk about knowledge sources, we have two main different categories. Indexed knowledge sources represent data which is actually going to get copied out of some original data repository. Maybe you've landed a bunch of PDFs inside a blob container. Maybe you've got a OneLake lakehouse full of relevant files. We're actually going to take those files and we're going to copy them into an Azure AI Search index so we can perform hybrid search with re-ranking on them. Remote knowledge sources are a bit different. Instead of copying the data directly into Azure AI Search, we're going to create a connection. Maybe you need to add information from the web. In private preview, we're happy to announce that you'll be able to bring any MCP connector as a knowledge source. Now, Sharepoint's a bit special here. You'll see it's in the middle of this Venn diagram. We're actually offering two ways to talk to Sharepoint. The first way allows you to copy files out of a SharePoint site into a search index. The other way is to directly query SharePoint using an end user's identity. So let's start off by talking a little bit more about how this remote SharePoint knowledge actually works. When remote SharePoint knowledge is queried, we actually are going to need the end user's identity. This is the person that's actually interacting directly with the agent, because we need to make sure that the documents that they have access to are only shown to them. We should not be showing additional documents. In this example, you can see an end user in a sales organization is asking about some executive documents they don't actually have access to. So we are actually going to go past that identity onto SharePoint. They perform the access control and trimming so that the relevant results of I don't know will eventually be generated. Note that if you already use Copilot, you're going to get very similar results here as we actually use the same underlying index on SharePoint that Copilot uses. For index SharePoint, it's a bit different because we're actually taking those files out of SharePoint and creating a copy inside your Azure Search index. We do this using an existing feature in Azure Search called indexers and skill sets. The indexer is actually going to be responsible for going out to the SharePoint site and fetching the files. The skill set actually takes those files and it chunks and vectorizes them, which is a very critical step to allow hybrid search to be successful. Note that even though we're actually copying the data out of SharePoint, we're actually going to preserve as much permission metadata as possible. And you can still use an end user's identity to filter the results that are coming out of SharePoint. So in general, any indexed knowledge source is going to use this same strategy. We're going to leverage the same indexer and skill set integration, and we're actually going to be using what are called skills, which are basically reusable components that apply AI enrichment to your documents from your data repository. This allows you to get the best search results possible. I want to really highlight a brand new feature we're also announcing at this conference, which is a better integration with content understanding. You have two main options when indexing knowledge from outside data containers like Blob and 𝗦𝗲𝗀𝗀𝗏. You could use a built-in free parsing strategy from indexers, what we call minimal. And just like the name suggests, we're going to be creating a minimal representation of that content, so we'll be able to be queried. But if your content has images, embedded tables, you're actually going to benefit from using the standard strategy, which leverages a content understanding deployment that you bring to create a significantly richer representation of this content. In the example you can see on the screen, you're going to notice that we have a flowchart. And if you were to use the default minimal strategy, this content would be completely missing. Because we're using content understanding, we're actually going to convert it to this figure tag, and the text is actually going to be OCR'd and made available so that if you were to use an LLM to reason over it, it could actually see the underlying text in the diagram. Now, when you're using knowledge bases, you're probably using this in a larger agentic context where you've got a lot of moving parts. And you're probably worried, how can I control the cost and latency from retrieval from my knowledge base? We offer a single control today we call retrieval reasoning effort. There are three main levels here. The first is the minimal effort, which is the cheapest option for getting information out of agentic retrieval. Low effort is a more balanced option that allows you to get good results at higher latency. And finally, medium effort is the step that's going to take the most effort to get the most comprehensive results.
Now, Matt, you seem to be missing a high.
That's a great point. In the future, we hope to extend retrieval reasoning effort to offer more advanced capabilities for retrieval.
Maybe a super high?
Maybe, but for now, these are the three options we have. So let's start off by talking about what this minimal effort actually is. Minimal effort is actually really interesting because it is effectively a way to use knowledge bases without any LLMs at all. You are giving up some advanced features like query planning, knowledge source selection, in order to get lower latency. If you need results out of your knowledge base fast, this is definitely the right effort for you. Now, note that because you need to do a query planning anyway, you have to actually give us the queries you want to run. This is a great fit whenever you want to combine an agent with a knowledge base. Now, let's go check out a demo of this minimal effort.
All right, so here I have the conversational RAG application, and this time I have agentic retrieval enabled. I've set that reasoning effort to minimal, and I have included Sharepoint, so it does have the option to search both a search index and Sharepoint. So this is a knowledge base that has two sources configured, a search index and a Sharepoint source. And you can see that I'm logged in. Thank you. So this is where I'm logged in, so that's the Sharepoint it would have access to. So here I've once again asked the question, what is the best 𝗲𝗲 paint for bathroom walls? And this time I actually get a slightly different answer because it has access to both the search index and Sharepoint. And we can see citations here, and some of these citations are actually files on the Sharepoint. Woo, that's right, Sharepoint. Now, if we look at the process that it used to get this, right, we took the user's query and we just directly, in this case, we just directly sent it to that minimal knowledge base. We said, hey, here's the user question. Just, just use it to search all the sources, right? So with minimal, it always searches every single source you have configured for that knowledge base, right? So it took that question and it sent it to the index. It sent it to the Sharepoint. It got back, like 6 results for the one, 2 results for the second one. All of those go through the semantic ranker and get merged together. And then we use our own model in this application in order to answer the question based off those results. So this is an example of how you might integrate minimal into an application. It is the easiest switch if you're already using like the search function of the search SDK and you want to start using multi-sources. The easiest switch is just to bring in minimal and try that out, and you'll find that you could kind of just swap it in there.
Yeah, thanks for that demo. That was great. Now let's talk more about the low effort option. Low effort is going to give you access to those more advanced features from the agentic retrieval engine because we're using an LLM. This is the mode that instead of just taking individual queries, it's going to take an entire conversation, run it through that query planning process, and break it down into these decomposed queries. Now, we run this knowledge source selection process as part of query planning. So in addition to getting those queries, we're also going to pick which knowledge sources we're going to use. Now, we send these queries to either remote or indexed knowledge sources to fetch the relevant documents. And finally, we have an answer synthesis option, so you can actually get a complete answer that you could render directly in your application. That includes citations. Yeah. So this query planning step that does knowledge source selection, let's talk a little bit more about how exactly that works. There are really 3 key factors in how knowledge sources are selected. We actually use that LLM to decide. So the 3 main inputs are the name of the knowledge source. You have an optional description. So you can give it, say, hey, I have a blob container that's a knowledge source. Maybe this blob container contains a bunch of HR documents. I have a 𝗏𝗏. It contains a bunch of invoices. And then the web should only be used in certain circumstances. So these descriptions are really critical to getting the most out of knowledge source selection when you choose to use it. Finally, you can also provide some custom retrieval instructions, which allow you to basically customize this selection process in natural language. It looks very, very similar to a prompt. Let's do a demo of the low effort.
Right. We're back to our application. You can see this time we have low effort enabled, and we're including Sharepoint, not including web yet. We'll see that soon. And this time I'm asking a more complex question. I'm asking which 𝗲𝗲 paint can I use to paint my bathroom, and how much does it cost? Now remember, this has access to 2 sources, a search index and a Sharepoint. And what we can see here is that it decided to only get results from the search index. I can tell that from the citations. I can also click on and see this thought process where we can see it does some query planning. It breaks down that query into multiple queries. So it says, oh, OK, I'm going to search for 𝗲𝗲 paint for bathrooms, and it gets back 6 results there from the search index. And it's also going to search for 𝗲𝗲 paint prices, and it gets back 10 results. So those must all be paints. And here you can see it actually decided not to search the Sharepoint at all. And actually, I agree with that decision, because when I set up the knowledge sources, I told it, hey, listen, if you need 𝗲𝗲 products and prices, just search the search index. That's where they are. That's the only place you need to go. So it decided that it wasn't worth searching Sharepoint, right? So this is a way that we can like save some costs where we don't have to search those sources if we don't need to. There is actually an option where you can say always query source. So if you are in a situation where you do want it to force query every source, you can do that. But it is nice to have this dynamic source collection because you can save time, you can save money, you can save tokens, and it can do a good job deciding. And so then we get back the results there. So that is low without web.
Thank you. So let's talk a little bit more about how this answer synthesis process actually works. The main feature that we're offering here, in addition to kind of pre-generating an answer, is allowing you to customize the style and tone with an additional set of natural language answer instructions. So we have a couple examples here to kind of illustrate how much of an impact you can have on the style and tone of the generated answer. The first example is this kind of default, what we get out of the box. And you're going to notice it's a little more verbose, which is good, and that's, generally speaking, a good starting place. But maybe you want to give it guidance to just, hey, answer with bullet points only. And my personal favorite is going to be a more stylized, poetic answer. So for that bathroom paint question we had, we can kind of get a much more poetic answer. You know, there's moisture in the air if you're in a bathroom. Semi-gloss shines, Strand's song here. Bathrooms, $47. So you can really customize exactly how this answer shows up, even a little bit silly, but it's a really powerful feature. So let's talk now about the web knowledge feature. Because many times your knowledge sources are going to cover a lot of internal information your organization would know. For example, it's like, hey, I've got manuals, I've got training information. But a lot of times your agent can benefit from public, up-to-date information that's available on the web. So by adding the Bing web knowledge source, you can actually fill in this gap. You are able to search the entire web or specify a custom list of domains. Now, note that in order to use this feature, you do have to opt into answer synthesis. That is not optional. So let's go take a look at a demo.
All right, so here we can see that we're on low, and we are including the web source. Now, this time we're asking, what is the best 𝗬𝗲 paint for bathroom walls, and how does it compare to other brand paints? So that's obviously a question that requires going out to the web to find out about other brands' paints. And so when we look at the answer here, we can see that there's, in fact, a lot of websites that are cited. We've got Fixer.com. We've got the ultimate paint brand comparison from Perfect Touch PTP, right? So it's gone out and found all these additional web sources. And we can look at the process here, and we can see that it decomposed that query into multiple queries. So it searched for best 𝗬𝗲 paint, and then it searched for comparison of 𝗬𝗲 bathroom paint to other brand paints. It searched the web for both of those as well, right? So it takes both those two decomposed queries and sends it to both the search index and the web, get back lots of results, and then merges those together and uses the answer synthesis in order to come up with a result. That synthesized answer still has citations. So you can see I can still make everything clickable. The stuff in my blob, the stuff on the web, they can reference everything to find out if they actually trust Fixer.com, right? Which is important, right? That's the whole point of these RAG applications, is to give users a way to get accurate information that they can back up with citations.
Thanks for that great demo. All right, now let's finish up the reasoning efforts here with medium effort. Medium effort is the one that actually adds this optional iterative retrieval step. This means that if the agentic retrieval engine determines that results retrieved from the initial search aren't sufficient to answer the question, we're actually going to do a second pass of query planning and retrieval to try to get a better answer. So we have a big problem here. In order to know if we have to do the second iteration, we have to actually decide how to do that. We have actually introduced a new model for the first time into the agentic retrieval engine. It's only accessible on the medium retrieval reasoning effort mode. We call this model Semantic Classifier. It performs really two key tasks that enable this confident iteration. The first is to decide, hey, is there enough information in the results of each query to actually answer the results of the underlying question? In addition to that, we also want to be sure we found at least one highly relevant document to answer the question in these queries. Now, if we don't meet these conditions, we're actually going to go and do that second iteration because we want to try to get the best results. So basically, this is allowing us to confidently iterate rather than just iterating all the time, which can be a big challenge in agentic RAG. Now, when the second iteration is performed, we're not just saying, hey, try again. We're actually passing additional context to that query planning that wasn't present in the first iteration. We're actually going to use the documents that were retrieved from the first retrieval and the original queries so that we can better formulate a more intelligent second pass that's taking into account the results from the first. So let's go take another look at a demo of how this looks like.
All right, so here we have Medium enabled, and we've got web, we've got SharePoint, and we've got our hardest question. So it says, explain how to paint my house most efficiently, then give me a list of the 𝗲𝗲 products and prices for each supply. So let's see what it decided to do. So it came up with a query, most efficient way to paint a house, a horse, that'd be fun. Then 𝗲𝗲 products and prices for house painting supplies. And this first query actually didn't get any results from the search index. It did get a lot of results from the web when it searched for efficient way to paint a house. Didn't get any for 𝗲𝗲 products because 𝗲𝗲 is a made-up brand, so it's a little hard to search the web for it. But hopefully all of you are working for companies that exist, and it's going to be easier to find you on the web. So then it looked at those results and said, okay, it found a lot of results that could answer the question about painting a house most efficiently, but it realized it couldn't yet answer the question about 𝗲𝗲 products. So it decided it needed to do a second iteration. And in that second iteration, it comes up with a new set of queries and source selection that will help it get a comprehensive answer. So in the second iteration, this time it searches the search index again, comes up with a different query, and it gets 4 results, right? It also did a bunch of other searches. It got more specific. It was like looking for drop cloths, caulk, like prep materials. Unfortunately, 𝗲𝗲 doesn't have drop cloths, but if it did, it would find it, right? So it actually gets very clever in that second iteration and comes up with some really good queries based off that first iteration to get much more focused results. So it can really help in getting much more comprehensive answers to these complex questions. And there we go. Oh, so all of the examples that I have been showing are from an open source repo. So, and this repo, we added the agentic retrieval feature to it today on Monday. It's been a very exciting week for us. And so any of you who want to get started with RAG, conversational RAG in your domain, definitely check out that repo. We've had thousands of developers deploy it. It's got tons of feature, multimodal, data access, cloud ingestion, just all the different features that people are wanting out of a conversational RAG solution. So certainly check it out. It can be a great starting point and great inspiration for all of you to see how we tackle common issues in these sort of applications.
All right, that's awesome. So now let's switch gears a bit and let's talk about how knowledge bases fit into Foundry. Azure AI Search knowledge bases are going to give us reusable topic-centric collections to actually ground our agents. Now, with Foundry IQ, we're actually able to take those knowledge bases using MCP to give our agents a unified knowledge layer. The result is going to be, it's much simpler to build agents. Instead of stitching a bunch of separate data retrieval tools together to get the same results you could get from a single knowledge base. Now, the magic question is, how exactly is Foundry IQ going to enable us to use knowledge bases to ground agents? So we are actually going to be using delegation, the same way that you might be familiar with the MCP protocol to use external services in your agent. You're able to use MCP to connect to your knowledge base. The agent is actually going to play the role of the query planner and the answer synthesizer here. As input, we're going to take a bunch of separate intents or queries, and the output is just going to contain the merged results. So let's check out a demo of Foundry IQ.
You want to do this one?
Yeah. So what I'm showing you here is the new experience inside Foundry. It's a kind of unified agent builder. So I'm able in a single place to see all my tools, knowledge, data, evaluations. This is a demo of the agent playground. So once I built an agent, I want to try it out, customize instructions. I'm able to use this UX to actually see how my changes make. So I'm using the same exact knowledge base that Pamela was showing in her demo, but this time I'm using it through an agent rather than through that deployed application. So when I ask the same question, what's the best 𝗬𝗲 paint for bathroom walls, you're going to see that I reach out to the knowledge base using MCP. I use this knowledge-based retrieval tool, which I then approve, and I end up getting an answer that looks exactly the same to what I got in the application. So this is kind of a great way to lift and shift your knowledge bases so you can actually use them inside your Foundry agents. Yeah. So that about wraps up our presentation today. I want to put up a call. You can feel free to take a picture of this slide. Again, we invite you all to sign up for the private preview of MCP knowledge sources. And we'd also like to open up the floor. If anyone has any questions that you'd like to share, please.
Do we have a mic? Oh, they could probably go there.
Yeah, there's a mic in the
All right,
center.
if you do have a question, there is a mic right there. You can come up and ask it. Don't be shy. We've got 4 minutes left to answer questions. There we go.
Yeah.
I have no idea how this works. No, I think you can hear us, so up to you.
Okay. I have a question with regards to the knowledge sources that you can add in the knowledge base. I was looking at it from the Foundry portal. I don't know, like on the Azure AI Search side. Can you add as a knowledge source only a specific index from like an Azure AI Search resource, or you need to add the full search resource?
That's a great question. So it depends. With indexed knowledge sources, what you're actually going to do under the hood is create an indexer and a skill set. So data from an outside source is brought into an automatically created search index. With remote knowledge sources, you don't ingest any data at all. You directly connect to an external source of information and query it at retrieval time.
Yeah, and with those remote knowledge sources, we get this question a lot. Like with Sharepoint, if you do need to filter the Sharepoint, you can use a filter expression. You could pass in like a site ID if you want to restrict it to a particular part of your Sharepoint, authors, et cetera. And similarly with the web, you can specify domain filters to just limit it to websites that aren't sketchy, right? It's a small list, but you've got these abilities that you can filter down those remote searches as well. We also have a survey slide, too.
Yeah.
Yeah. We do also have this QR code for you to give feedback about the session, and you can scan that QR code in order to fill it out. We have a couple more minutes if anyone does want to go to the mic. Of course, we'll also be here after the session to answer any questions that you don't want to ask in front of everyone.
And again, we thank you all so much for joining us. I know it's pretty late in the day, so thank you very much for attending our session.
Thank you for joining us at Microsoft Ignite Silent Stages. Please leave your headset at your seat as you exit.
All right,
Thank you for your cooperation.
Could I ask a question?
Oh, of course.
Yes.
This is like magic. You've kind of taken what I wanted to build and commoditized it. So I think you're like, this is
Can you go
amazing.
closer to the...
Yeah.
Yeah, so this is kind of, you've commoditized exactly what I think we need to do to provide agents and knowledge bases. I wonder, is there any worth of storing graphs and relationships of separate entities, kind of more the connections
Yes.
between certain entities?
Yeah.
Does that have value in the knowledge base, or is that something that you confer anyway?
Yeah. So I can tell you that graphs are something we are very interested in as well. We don't have a built-in graph, but if you can join the MCP private preview, if you have a graph database, you are able to add that as a knowledge source.
Awesome, thank you.
Of course, thank you.
So what kind of chunking strategies do you recommend? When you use this from the portal, we don't get a choice of the chunking strategies.
So we offer a built-in chunking strategy, which uses some defaults. So there's two options. The first option is you can do the chunking totally yourself, push the data into the search index, and you have complete control. The second option is to use an indexer with a custom skill set. And we actually have a built-in skill called split skill, and you can customize the chunking strategy to some degree on that skill, or you can define a custom skill that does the chunking completely the way you want it. Actually, in the repo, we added support for custom skill sets, and we use our custom chunking strategy with the built-in indexers that way.